Hello, all. Happy November. What is today? It's November the 11th, 2023, and we've had a big PyScript release this week. PyScript 2023.11.1 is out, finally, after months and months of working on it. It's out, it's in the wild, and we're so excited to share it with all of you. A little bit of business before we just dive into all the new features on the new release of PyScript. One is if you're here watching this live in November 2023 when it comes out, feel free to ask questions in the YouTube chat and I'll do my best to answer them. Whether it's questions about how does this work? Can you explain more? Or like what happens if you try X with Y? Happy to do my best to see what happens. Usually I don't know. We'll find out together. Similarly, if you're watching this after the fact, feel free to leave questions in the comments and I will do my best to answer them there. Or come join us on the PyScript Discord, which is linked in the description of this stream/video. A great place to ask questions in real time and get some answers there. All of the core devs for PyScript hang out in the Discord, so it's a great place to ask technical questions or usability questions, and we'll do what we can. I think that's all of the preamble. So I guess without further ado, let's dive right in. Like I say, that today's stream will be focused around PyScript 2023.11.1, which was just released. Let me see here. Here we go. So a couple of new things to note sort of right off the bat compared to previous releases of PyScript. I will say just sort of like one point of terminology as we dive in here. This is not really official, but internal to the team, we've been referring to this release of PyScript, which has been coming for a long time, as PyScript Next, sort of a big iteration of PyScript coming up, and everything that came before this as PyScript Classic. So if I slip up and say, a new feature in PyScript Next, that just means from release 2023.11.1 onward, and PyScript Classic is everything before that, if that makes sense. Like I say, that's not official. It's not being like on the GitHub anywhere. That's just like what we are calling it. So one thing that is true in PyScript Classic in PyScript Next that was not true in Classic is that our links look slightly different. You can still include PyScript in your HTML by adding a script tag to the head or body of your HTML document. Unlike PyScript Classic, things look a little bit different here. In PyScript Classic, see, I guess I'm going to use that terminology a lot. It's just a useful moniker for like, every version of PyScript before this one. So in previous releases of PyScript, the script tag looked like this. So for example, our last release, 2023.05.1, you would do a script with a defer attribute, which was required, and then you would point to releases/2023.05.1.pyscript.js. Now your script tag is going to look like this. The defer attribute is no longer required, but you do need to specify a type of module to execute the PyScript core. And similarly, the name of the JavaScript file itself is core.js instead of pyscript.js. Just to sort of emphasize, like there are other importable PyScript modules that are being published both through GitHub and on NPM, and we thought that like calling one of these things just PyScript was a little bit confusing. So now we're going to call this the PyScript core, and other things might be, core, might be PyScript/extensions or PyScript/terminal or something like that. So this is the format of the script tag that you want to be using now to include the latest version of PyScript in your page. Let's see, over on the right-hand side of the screen here, let's load a live copy of what we're seeing, and we can see that we are running PyScript live on our page. One more note before we get into the actual Python code itself, I do just want to show you what happens if you forget this type module specifier. I'm going to open up my developer tools in Chrome here. I'm going to open up my console. I've made the font size quite big, so hopefully you can see it. Yours probably won't appear quite this big. You'll see I have basically no messages in the console, but if I delete this type of module and reload my page, I very quickly get this slightly cryptic error. Uncaught syntax error, await is only valid in async functions and in the top level bodies of modules. The keyword here is modules. The PyScript core is now written as a module, as an ECMAScript module, and so to use it, you have to specify that you are loading a module, and if you do, your PyScript code will run just fine. Make sense? I like to mention that here because that error message is not terribly descriptive, and it's not something we have on PyScript side any control over, because it's an error based on how you're loading PyScript core. So if you load it wrong, we don't even get a chance to like throw an error message in there because, well, we haven't loaded our module yet. There is also CSS associated with PyScript if you want to load it. It's pretty minimal. It's at pyscript.net/releases/release number, again, /core.css. If I open that up, it's actually, this is the entirety of that CSS module. You can see it's just hiding some of the display, the elements that you might put on the page that you don't want to be physically displayed. You can include this, you cannot include this. I do here just because it cleans things up a little bit. But again, all of the core business of PyScript is included in that JS file. So that's really the important thing. If you have used previous releases of PyScript, something that looks different this time that you might see on this page is our script tag. In previous versions of PyScript, you would always be using a tag that looked like this, py-script. And you notice here in my example, I'm using a script with a type of Py. So what's the difference? Well, both of them still will work. In fact, let's do another example down here. I'll say from PyScript import display. And I'll say display, this is a PyScript tag, right? If I save that, which will make it rerun, we'll see actually both of these snippets of code run the script type Py and the PyScript tag. So what's the difference and why complicate things? Why have two tags that do essentially the same thing? Because they do essentially the same thing. They allow you to write Python into your HTML, right? That's the pitch of PyScript, write Python in your HTML. Why have two differently looking tags that allow you to do this? And the reason is we were in PyScript Classic playing just a little bit fast and loose with what these custom elements are meant to do. They make use of something that's available in all browsers called the Custom Element API. And that allows you to say, hey, you browser, you know about the p tag, you know about the div tag. I'm going to tell you how to use a new tag, a PyScript tag. And please take certain actions, Mr. Browser, when you attach this element to the DOM, when you remove it from the DOM, when you move it around. The browser says, sure, I'll run your callbacks whenever I move this element around or something like that. Totally fine. The thing is, a custom element is always a displayed element. It is always assumed to be something that should be integrated into the flow and structure of how the page is parsed visually. And that's not necessarily always what you want. And in fact, is different from how script tags are treated. Script tags get specialty treatment by the browser. They are never treated as something that can be displayed. They are ignored for the purposes of like page flow and layout entirely. And what's more, their contents are never parsed as HTML. When a browser encounters a script tag, it essentially says, okay, there's going to be some kind of code inside here, clearly not HTML that I'm supposed to display. I'll stick it aside, and if it's JavaScript, I'll execute it. If it's some other type of code, someday somebody else's code will tell me how I'm supposed to manipulate this. Where this pops up is where when you start putting things that look like HTML tags inside of your PyScript tag. So for example, in my PyScript tag down here, if I type something that looks like HTML, maybe put an H1 tag in here, and to hit display. Actually, we'll see how badly this breaks. Oh, display. Oh, so very nicely. So display does auto escape. I think if I, let's see, if I include this as a not broken one. Yeah, so there we go. So we can see here what's happened is the page has come through, the browser has come through and parsed my HTML document. And when it got to this H1 opening tag, the browser said, okay, well, I assume that everything else following it is an H1 tag. And it's missed the fact that actually what I wanted to do was include, open brackets, H1, close brackets inside of this string, because it doesn't know that what's in here is meant to be code. It just says, hey, this is some text. It might contain other tags inside of it. I'd better parse this as HTML. And that breaks our Python interpreter quite badly. It's trying to actually parse this entire HTML file as some Python code, which is not what we want it to do. The way to solve this is to use an actual script tag. So I believe, and here's the excitement of doing live demos, we'll make sure this actually works. If I put that H1 tag inside of my script type Py, what I should see is that there are no parsing errors at all, because what's inside of a script tag is never parsed as HTML. For this reason, and for the sort of visual layout reason I mentioned earlier, we are recommending with the newest release of PyScript that you always prefer script type Py over a py-script tag. They both still work, and they should work identically with all of the additional attributes you can add to these tags that we'll talk about in a few minutes. Things like async and worker and terminal should work identically on both tags, but script type py avoids this sort of nasty class of parsing errors that the PyScript classic tag has. We might deprecate this someday, we might not. That's sort of a hotly debated thing because this is sort of the banner feature of PyScript, right? You have a PyScript tag, but from a browser standards perspective, this is always going to be preferred to use a script with a type of py. So that is my recommendation for you. So that is the two big changes in sort of basic layout, right? Our script tag looks different to get PyScript on the page, and you should be using script type py wherever possible. Let's see here. Sorry, I'm looking through my notes to make sure I don't forget anything and do things in the order that I wanted to do them. Before we get into the attributes you can now add to a PyScript tag, let me show you a different type that you can run with entirely. We'll get through a few things here. If you have a script tag with a type of py, you are loading a copy of the pyadide runtime. And this is the same as it's been in PyScript Classic. Pyadide is a project which basically takes the whole CPython code base, Python as we know it, and compiles it to WebAssembly so it can run in your browsers, right? So when you're running PyScript code, you are running with a full copy of CPython client side in the user's browser, which is awesome. That does mean, though, that whenever the user loads your page, they have to load a full copy of the CPython interpreter, and it's been precompiled to WebAssembly, and there have been a number of optimizations made to try and shrink that download as much as possible, but it is still about a 5 megabyte download on page load, and after that, depending on your system, there's probably a second or two where that interpreter has to start up before it can actually start running CPython code. For a lot of applications, this is no big deal, right? If you're going to be doing some heavy data lifting on the client side or, processing data frames or matplotlib, you're probably in an environment where the user is willing to tolerate a couple seconds of startup time. But for other webbish things, right, if you just want to write Python to run a website, every millisecond matters, and speed is super critical. And so that, 5 megabytes of download and 2 seconds of startup might be more than you want to tolerate in your app. So there's a number of ways you can deal with this, but one of the most exciting that's new in the PyScript release we've just had is that you don't have to run purely with CPython. You can run with Micropython. And the way you do that is to change this script type py to script type mpy. If I do that, here, let's see. Let's do a side-by-side example. I will say, let's surround this in some content so we can see what's happening. I'll put a couple paragraph tags in that say first and second. And in the middle here, let's go back to script type py for a second, and I'll say print PyScript is running, right? So if I hit save, we'll see the content refresh here, and after the pyadide runtime downloads and runs, I should see, well, if I don't have an error, which maybe I do. Oh, I see. I did print instead of display. Let's use display so it shows up on screen. From PyScript, import display, PyScript is running. Let's close that up again, and I'll hit save now. And after a couple seconds of startup, we get PyScript is running there, right? So, on my system, in my environment, a second and a half, 2 seconds is not unreasonable for CPython startup. If I go to mpyscript, and I hit save now, it's almost instantaneous, right? You could see that little flash of text there. I'm actually not even seeing on my screen. Maybe you can see it on stream better than I can. I don't ever see first and second next to each other. I just see Micropython starting up, which is really cool. So the startup time here when I did a measurement test was 2-ish seconds for CPython and under 200 milliseconds for Micropython, which is super exciting. I should say, for those who have not encountered it before, Micropython is a variant of Python that was originally developed to run on microcontrollers. So it is prioritizing memory use and speed and optimization and fast startup time. And so on the web, where those things are also super critical, that's a really cool tool to have in our pockets. I will say Micropython is not identical to CPython. It's a re-implementation of the majority of the Python language. But there are things that differ. For example, the object model, the underlying object model is somewhat different for memory efficiency, which means that MicroPython is not compatible with most CPython standard libraries, right? You can't run NumPy or SciPy or Pandas or any of the heavy lifting C integrated libraries directly in MicroPython. So if those are things you need, CPython and Pyadot are probably the way you want to go. But if what you need is speed and to write some Python code, MicroPython is a really cool, really lightweight option. I recommend you check it out. And we'll keep touching on that as we go through with our various ways we can run Python and MicroPython as well. All right, next on our list, let's dive a little bit deeper into ways you can modify a PyScript tag to have it do other things as you run. I see Piers has a question. It's already been answered. Yes. How do you actually run with MicroPython? Yes, you can use script type mpy to run it. You can also, throwing back to earlier, you can also use a tag like mpy-script. mpy-script will work. But for the reasons we discussed earlier, I would recommend using script type equals mpy for all of your MicroPython running needs. Some attributes you can add to a PyScript tag that will allow it to do different things. We'll add a script type equals py. Tag in here. You've noticed so far that I've been writing all of my code inline. I can write it inside my HTML, right? And from PyScript import display. And we'll talk a little bit more about that display built in a little bit for those who haven't seen it before. We'll do that down the road. I will say display hi. I'll have that run. And it'll update my browser over here and it displays hi. So you can certainly write your code inline like this, right? That's PyScript's pitch, write Python in your HTML. But once this code gets somewhat longer, writing it inside of your HTML file directly is not necessarily the best way to go, partly because none of our IDEs are going to understand that this is Python code, right? VS Code, which is what I'm using today, doesn't know that script type py means Python. And there's been some work with the VS Code team to try and sort of bring that advanced syntax highlighting to there, but it's not currently implemented. So one thing I like to do once this becomes more than a few lines of a demonstration code is move this Python code into another file. So let me open up my Explorer here. You probably can't see that tiny little font size, but I'll create a new file called main.py. And inside main.py, I will just cut and paste my Python code and save it there. And then back over in my index.html file, I will say script type equals py, source equals main.py. Right, and now if I rerun that, what I should see in my browser is I get hi. Maybe I'll make this do something slightly more Python-y, so we can prove it's running Python and not just emitting strings. I'll say for I in range 5, display hi, and we'll throw the number from our loop in there. So when that runs, we should see hi 1, 2, 3, 4, hi 1, hi 2, hi 0, hi 1, hi 2, etc. Right? So the source attribute basically lets you reference a separate file via a URL that allows you to move your Python outside of your HTML and into a .python file. And of course, now we have all of our nice syntax highlighting and linting and anything else we want by putting it in an environment, in a .py file that the IDE understands, which is quite good. So hopefully no surprises there. Source can be a relative URL. It can be a fully qualified URL, somewhere that points to a file that contains your Python code. Other things you can have as modifiers to your PyScript tag. Oh, here's a cool one. I'm going to move my code back sort of inline here, just because I think it's going to be a little easier if I can keep all the sort of the full demo on one view, if you will. Like I say, most of the time I'm working with my Python in a separate file, but because I want all of you nice people to be able to see it all in one place, I'm just going to put it back here. If you're watching live and you have strong opinions that I do it the other way, I don't know, put it in the chat. But for now, this is what we'll do. We'll just rerun this and make sure that it's working. I guess it's not really changing the view out here. Maybe I'll do, well, this will be fine for now. For what I want to show off next, actually is going to modify this, which is the async attribute, async, which does a fairly different thing to JavaScript's async attribute. So for you web-originated people here, script type py async is not the same thing as script async. Here's what the async tag attribute does in PyScript. When you are writing normal CPython code and you want to use a coroutine, you would normally have to do something like this. From async.ao, import ensure future, for example. or run task or something like that, we could define our coroutine with async def. We'll call it corow, and let's we'll import sleep as well, and we'll say for I in range 5, we'll display I, and we'll await sleep 1, and then we'll schedule our coroutine, ensure future coro. So this is a really basic coroutine that should be displaying the numbers 0 through 4 and sleeping for 1 second after it does each of them. I'm also going to need to do from PyScript import display. So if all has gone well, if I run that code, we'll see. This whole thing is going to be live demos. From async.io is not defined. Async.io. Why is async.io not defined? Oh, it's because I see it. The error is actually down here. I just can call it as ensure future because I already did that import. So I should see 0, 1, 2, 3, 4, right? So async.io's and coroutines work perfectly well inside of PyScript because we have a full copy of CPython. And there's integration between the browser's event loop and the async.io event loop. I don't know. We're down in the weeds of async.io-ish stuff. Suffice to say, like, this is quite a bit of a boilerplate for something that essentially wants to count from 0 to 4, sleeping for 1 second in between, right? We have to sort of import these things from async.io. We got to understand a little about what ensure future does. I have a whole blog post on that, but it's a little bit cumbersome. Like, I know not everyone loves async.io. So PyScript Next has a neat feature that obviates the need for a lot of that, and that is the async tag. What async does is allows you to run with a wait at the top level of your code. So what I'm actually going to do is just delete my async def. I'm going to delete my ensure future. I'm going to put my await right in the top level of my module. And then if I haven't made a typo, this should just run the same as before. So yeah, so you get 0, 1, 2, 3, 4. So what's happening here is we are allowing our Python code to run with what's called top level await, which basically says if I see an await statement in a normally forbidden place, I will just treat all of the user's code as a coroutine and just run it, right? Normally, if in CPython, if you have a floating await here outside of an async function, it throws a big ol' error, right? Oh, here it is, syntax error, await outside function. Like, this is not allowed in CPython. But we've added this nifty async attribute that allows you to say, hey, like, listen, the user's going to want to do some async-ish stuff and just run some coroutines, put the async tag on there, and your whole script can run as normal. There is no harm in adding this async flag to non-async code, right? If I get rid of that piece of code that has await in it, this code will still run just fine. In fact, maybe I'll change this to 10 just so we can see a visual update that it is still running. Yeah, so that runs just fine. What this async allows is it allows you to include these top-level awaits in your code, which is very convenient if you're doing this kind of async programming or coroutine stuff. So that is the async attribute, which I like a lot. It's really helpful if you're running code inside of a REPL, and we'll look at the built-in REPL in a little bit. It makes it easier for you just to like write coroutines into a REPL, rather than sort of like having to go through the ensure future step to run any of them. Other attributes you could add. Okay, let's do a simple one, and then let's do a big ol' exciting one. The simple one is target. So we can take the target attribute, and it takes a selector in the DOM, maybe something like foo, and let us, again, put some content on the page just so we can see what we're doing. We'll do a paragraph tag called first, a paragraph tag called second, and a div with the ID of foo. Let's delete a little bit of code here. We'll leave our import of display, and I can leave this count here. If we leave our target element out, our target attribute out, what will happen here is when you call PyScript's display function, which is the function that PyScript uses to stick content onto the page, it will display essentially in the same place on the page where your PyScript tag is, right? If I do an inspect here, it's going to be a little cumbersome with like font sizes, but I think I can show this pretty well. If I look at where these numbers have ended up in our page order, we'll see we had, just like our source first, our foo div we'll use here in a second, our second, our PyScript tag itself, and then right after it, we basically inject in the same place on the page all of the output that display produced, right? So by default, display sticks it where the PyScript tag is. But that's not always what we want. Sometimes we'd like to stick the output or the visual output from our code in a different spot on the page, and that's one of the things you can do with this target attribute. So if I add target equals, and I'll give it a selector, right? So this is the ID of foo that I want to match, and I run this code. What I should see is that now, if I open my inspector, that content has been put inside our page element that matches that selector. So in this case, I gave it an ID of foo to match against, and it stuck the output from display inside the div with the ID of foo, right? This is a real easy way to say, hey, everything inside this tag that uses display, stick that output not where I am, the tag, but rather with the inside of the page element that matches the selector. Does that sort of make sense? I will also say, so this is a way to do this at a full tag level. You can also do it at a per display level. So I can add a target attribute, a target parameter argument to the display call itself. And I can say display this in foo, but I could say display done with no target attribute. And now what we should see is that the calls to display that targeted foo ended up inside of our foo div. But this call to display that didn't use a target argument ended up where the PyScript tag is itself on the page. So the target attribute, as far as the tag is concerned, basically sets a new default location on the page for calls to display to stick their content, but you can also always add this target argument to display directly. I said that about 6 different ways, and hopefully one of them made sense to you. I should say this is also fully explained in the PyScript docs, docs.pyscript.net, which if you haven't stumbled across and you're interested in PyScript, I fully recommend checking out. All right, that was, in theory, the simple attribute, which I feel like I made a little bit of a mud puddle of. But now let's do the more complicated one. Let's clean this up a little bit here. We will clean this up, and I will take us back to just printing the numbers 1 through 5 so that I can show off maybe the most exciting feature of this new PyScript release, which is web workers. So if I run this here, this will bootstrap, and it should run just the same as before. Let's see if that's true, or if I've made a typo. There we go. I have a shared array buffer due to insecurity requirements error. This will be something we'll get to talk about in a second here. There's one more thing I need to do to make this work. But first, let me explain to you just a little bit about the concept of web workers. I'm going to try and do the 30-second version, and I will hope that the webbish folks in the crowd will forgive me. The browser window, when you run it, gets one thread to do everything, right? So when I'm looking at this big blank browser window here with nothing on it, there is one thread handling everything on this page. Similarly, if I go to like google.com, for some search I did recently, like everything that happens on this page, all of my notifications, all of my user icons, rendering, reactivity, all of that runs in a single thread. And that's a pretty serious limitation, right? We are used to web pages doing all kinds of things at once. We might be, updating UIs. We might be running animations. We might be doing all these things. And so the history of web development, in a way, is ways to make a single thread do all these things at once, mostly by using async functions and callbacks. And so that requires a certain dynamic style of writing your code such that your code isn't fully locking up the one thread you have to work with, so that your page can continue to do other things. To prove to you that this is the case, let me see here if I can let me lock up my page for you, and you'll see what I'm talking about. So I'm going to really quick add a button on this page that does something, so that I can show you how it doesn't work. Alert, actually, we'll see. Alert might break it. We'll see. Click me. So when I click this very fancy button I've just added, you probably can't see in my tiny text up here, but it says hi, which is the message that I passed to alert. This is a JavaScript function, right? My page is running some JavaScript when I click the button and it's saying hi. If I do a very long running piece of Python code, I say for I in range, I don't know, let's start with 1,000,000. I will say x equals 0. Just do something inside of that loop, right? And I reload my page. Ooh. Oh, I snuck in a bunch of clicks to alert. Now I can't even close this modal here. I'm clicking furiously and it won't even let me close. here, let's make it clear when this has finished. Display from PyScript import display, and I'll say display done. Maybe we'll do a display starting as well. Just so we can, I guess display done will be the one that'll be most relevant. So if I run this code, we'll see it runs, it bootstraps PyDide, and it prints done. So I'm gonna actually make it wait a little bit longer. I'm gonna rerun this code. PyDide will start. It waits, prints done. Let's make that even longer. Let's do 100 million. I'm really trying to find a thing that's going to like lock up my system for multiple seconds to make it obvious what's happening here. And this is taking now a good, like, I don't know, maybe 20 seconds to run. We still don't have our done statement. And while it's running, like, I can click this click me button all I want. And only when things are all not quite locked up can anything happen. Basically, by running Python code synchronously in the browser, I've taken up the only thread that we have available to do work with. And nothing can happen until after that work is done, right? I have one synchronous piece of code, and it's taking up the entirety of that thread. And that's really frustrating. Like, I would love to be able to, as a web developer, just say, hey, go off and run your Python code, and then come back to me with the results, and I'll do something with it. But there seems to be no reason why, I've fully broken my browser at this point. Why do I have to lock up the one thread I have to work with doing this work? Yeah, I'm going to have to, like, close and restart Chrome to make this happen. Let's do that. Let's relaunch a copy of that page that's not as broken. Ooh, I should probably change this source. Oh yeah, look, Chrome's really busted. Oh, that's exciting. Here, reload this. Okay, let's try this again. Let's reload let's reload another copy of that page. Okay, so now I just have the button and it works as we intended. So this is a problem. We really would like to be able to go off and do some work in Python and then come back to the page and do something with it. And the way you might do that is by using a web worker, which is a way that, after many years, web developers and browser developers said, hey, it would be great if we could have some additional threads to do some additional work with. And so the idea of a worker thread was created. It's a way of spinning up an additional thread that you can do work in and then report back to the main thread with what you found. When I ran this earlier, and actually I guess I should put some code back in it, from PyScript import display hi, just so we can see it running, or in this case, see it not running. We'll see I get this error, unable to use shared array buffer due to insecure environment. Please read requirements at MDN. So what this error is telling you is that in order to run with web workers, and I know we're deep in the weeds on sort of web development side stuff, but it's worth learning about so you can use web workers in PyScript. All right, I digress. What this is telling you is that essentially there are very limited messages that you are allowed to pass back and forth between the browser window's main thread and these worker threads. You basically are only allowed to pass strings back and forth via a mechanism called post message, or if you are running in an environment with a certain amount of trust in your system, you can use these things called shared array buffers, which are just what they sound like, right? Essentially an array that both the worker thread and the main thread are allowed to share. But by default, those are not enabled. You have to serve your web page with the correct headers enabled. And my little VS Code Live server here is not serving them with the correct headers enabled. So there are many ways to enable those headers, and I'm realizing I didn't bring in the one of them that I intended to use, but I can grab it real quick. One of the ways is, right, if you are developing your own website, the thing you would want to do is basically enable COI and headers in your sites, in the headers that you are serving your pages with that you want to run workers on. You want to enable COEP and COPE, I think, or CORP. I confess all of the C acronyms get mixed up in my head a little bit here. But if you are familiar with web permissions and servers, there's a pretty standard way to enable those. The easier way to enable those in your code, and the way that I often sort of defaults to, is using one of a couple of libraries that set these headers for you automatically on your page. One of them that I like very much is called Mini COI. It is linked in the PyScript docs. You don't have to memorize it. It's by Andrea, who is one of our PyScript core developers on github.com, github.com/webreflection.minicoi, and I will link this in the description of this video when I am done. Essentially, it is a single JavaScript file that you can include as a separate file in your hierarchy. And if you load it into your page, it will just set the headers for you. Really what it's doing is creating a service worker that sort of shims out your server and injects itself as your server and runs it with the correct headers. In any case, a bit of a digression. But what it means is that if you include Andrea's code as a separate file, in my VS Code here, I'll call it minicoi.js, and literally copy and paste the code from that repository. And it does, by the way, have to be a file that exists on your system. You can't link to like the GitHub copy of it, because the reason that it works is because it's served from the same place as your files. So I'm going to create a local literal copy and paste of that one JavaScript file called minicoi.js. And then in my HTML, a little more room here. In my HTML, I will just say script source equals minicoi.js. And now, if I reload the page and everything has gone well, I should see, oh, there we go. I got height. So what has just happened here is that PyScript has, on seeing this script type py tag with a worker attribute, it's spawned one of these web worker threads, loaded up pyadide in that web worker, and run all of my code in the web worker rather than blocking the main thread. And this is really quite cool. So for example, if I bring back that awful code from earlier, right? I say for I in range, what was it? 100 million, I think was the one that was problematic. X equals 0. Display done. If I run that and come back over here, now clearly that code's going to take quite a while to run, but the important thing is my UI is not fully locked up because all of this Python code is being run in a separate worker thread. This is really super cool to be able to sort of run Python code in the background. Oh, and there it is. It's done. So just if you had any doubts, that Python code was running all the time that I was messing around with my clickbeam button here, but my UI wasn't locked up. And when it was done, it ran the sort of end of my display code and displayed done on the page. So if you have any kind of, sort of heavy lifting to do in your Python code, I really recommend doing it inside of a web worker. It will keep your main thread free for interactivity, for other JavaScript libraries, for what you have. So this is a huge new add that we have only in this new PyScript release that didn't exist before. I encourage you to try it out because it really adds a lot of power to the things you can do with PyScript. A couple more details on that. Anytime you have a PyScript tag with the worker attribute, you are spinning up a separate thread to run that PyScript. So just to do a really dumb example of that, why don't I say from PyScript import display, x equals 0, display x. And if I make a copy of this PyScript tag where I just say display x, these two PyScript tags are going to run in separate worker threads. The first will successfully display 0. The second will error out, and it will show my error in my developer tools here and say name x is not defined, right? So these are literally two different copies of the CPython interpreter running in different worker threads. So that's something to keep in mind as you're implementing this. If you are for every separate script tag with a worker attribute is a different thread. Make sense? I believe async as a tag works with workers as well. I don't think I've actually tried this, but let's find out. From async.io, import sleep for I in range 5, display I, and await async.io.sleep 1. I think this works. Like I say, I don't think I've actually tried this. This is one of the fun things about doing these demos live. Is I actually don't know. Oh, it's just, sorry, I imported sleep from async.io instead of doing async.io.sleep. That's on me. 0, 1. Yeah, there you go. So if you need to do coroutine-ish stuff and you also want to do it in a worker, you can mix these two tags to your heart's content. Totally fine. Worker is meant to sort of be a relatively transparent way of offloading your Python code to a web worker. which is mostly successful. So anyway, if you've played with PyScript in the past and you've been like, oh, it really sucks just like how long it takes to boot up PyScript, and then it runs my code, and then it's locked up my UI for that whole time, throw a worker tag in there and just see how well it now works. It's really very cool. Along those lines, I do want to mention one thing about interacting with the page, and how that interacts with the worker tag. Littlebug says, sorry, a quick question here. Very nice feature about working with workers. How do we share information between different threads? Yeah, it's a very good question. There are a couple of ways. One would be to pass that information through the main thread, or through the main the DOM, which is the document object model, which is to say the web page itself. For those who are not webish, you might not have encountered the term the DOM before. It just means like the contents of the HTML on the page, the DOM. And I will show you an example of that just now when I talk about importing objects from the JavaScript global namespace and how that relates to web and web workers. Okay, let me take a step back. And Littlebug, I apologize. This is going to be a long way around to answering your question, but I think it's going to be more illustrative to sort of pass through some of the more fundamental stuff first. So, in Pyodide and in PyScript, and actually now in Micropython as well, there is a very cool thing in that we get to interact with the page contents more or less directly. And by that I mean that we get to interact with the JavaScript global namespace to do stuff. So let's put some stuff on the page and I can show you what the heck I'm talking about. Let's put a paragraph tag in here. Let's give it an ID of my stuff. And we'll say, Littlebug has a question. It seems topical. So that is an element that will exist on our page. If I want to, say, grab this page element and do something with it in Python, Pyodide and Micropython's FFI allows us to do that. And in PyScript Classic, you would have done something like this. I'm going to actually say PyScript Classic. You would say from JS import document. Let's see, let's call it p equals documents.get element, get element by ID, my stuff, display, we'll make it an f string, the contents are p.text content. And if I've done this all right, and again, I'm creating the demos live, so it's certainly possible I will mess up something at some point. Oops. What is this? What is my name error here? Name display is not defined. Oh, yes, I have to import the display function from PyScript. From PyScript, import display. And if I've done all that right, I should see contents. Littlebug has a question. So what the heck is going on here, right? If you come from PyScript Classic, you know a little bit about this already. If you're coming in new, hopefully this will be as mind-blowing to you as the first time I saw it. What's happening here is when we import from JS, right? And that could be import JS or from JS import an object name, what we are actually referencing is the JavaScript global namespace. So in your web browser, and if you're opening your developer tools, there are a whole bunch of objects that are loaded as part of the JavaScript execution engine of your browser, whether that's like V8 in Chrome or SpiderMonkey in Firefox. If you start typing in your developer tools, you will see things like the document object. Document. If I autocomplete it, we'll see I have a reference to a document. I have all of these various methods and objects and things that I can use. The clear interval function, the class keyword is in here, right? All of these things that are available for your JavaScript to use when it runs on the page. We can access all of those functions and objects inside of Python by importing them from this JS pseudo namespace, right? So when I do from JS import document, what I get is a proxy for the document that exists in JavaScript. And I can call all of the methods and elements, the methods and functions and attributes of the document object in Python that I would normally have in JavaScript. So for example, right, what I end up doing is saying, let me learn about the document object, and I'll look it up on the Mozilla developer docs, which are a great resource for learning about these things. I can say, in JavaScript, what is the document object? And it says, oh, document is represents any web page loaded in the browser. And it has all these instant properties like if I search for get element by ID, I see I have this get element by ID function. So to be clear, this is a method that exists on a JavaScript object that I can call in Python, right? I'm calling this function in Python directly, and it pretty much just works. How cool is that? Anyway, that's the basics of JavaScript Python interaction in the browser, made possible by the Pyodide and Micropython FFI. Super cool. Here's the caveat, and again, Littlebug, we're gonna take one step closer to your question, right? Access to specifically the document and to the window, to the page as a whole, is a privilege that only the main thread gets. One of the biggest limitations about web workers is that they don't get access to the DOM. And I think we can just break this right away. If I take this existing code and I throw a worker tag on it, I believe it's just going to throw an error. Yeah, it sure will. It'll say, cannot import named document from JS, unknown location. So what's happening there is this code, which is now going to be run inside of a worker thread, cannot find access to the page, the document, because, well, worker threads don't get access to the document, don't get access to the page. And that's a pretty significant limitation, given that a lot of what we want to do in our code, whether that's JavaScript or Python, is interact with the page, receive events, put output to it, and so on. So PyScript has implemented a what I think is a pretty nifty workaround, which is something like this. Instead of saying from JS import document, I'm going to opt to say from PyScript import document. And actually, I might as well combine these two import statements into one line, right? Import document and display. So now if I run this code, what I should see, and hopefully it works, is the same thing we saw before. Contents, Littlebug has a question, right? While from JS import document tries to grab the document object from wherever that code is running, from PyScript import document always grabs a reference to the document object that's available in the main thread. So if you do from PyScript import document, you will always get a reference to the real deal pages document object, whether you're running in a worker or not, right? If I rerun this code in the main thread, we should see exactly the same thing. Wow, Littlebug has a question, right? So this is a really nifty workaround that PyScript Next has added, giving you access to the document on the main thread, even though your code is running in a worker. For those who come from webbish things, that's a little bit spooky. But a very, very convenient feature. It allows us to work with workers and Python in a really sort of transparent way. So to get back to your question, Littlebug, and I probably won't be able to like code up a massively impressive working demo off the top of my head here. But one thing you could do is in two separate worker threads, you could code up basically the ability to pass information through the DOM or through sort of the main window in this way. Actually, let's. I'm gonna try something now. Full caveat, right? We're off the syllabus a little bit here, so this may be broken. And if it is, then come hang out in the Discord and we'll work up a solution together that actually works. But I do want to give this a try. So I'm going to say from pyodie.ffi.wrappers import add event listener, which is a real easy way to make some of your Python code listen to things that happens in a DOM. And I will say def double change, which takes an event, and I will say print event.target.text content. This is all going to make sense in a second as I sort of type and code at the same time. And I will say add. Let's see. Let's do from PyScript import document. We'll make our paragraph tag here. Let's see. How do we want to do this? Let's give ourselves a place to stick some content. We'll say ID equals content. We'll make our content appear inside of that tag using the target argument to display. I will grab a reference to that tag in my other worker thread. I will say cont equals document.get element by ID content, add event listener cont. Let's see. Maybe I probably have to look up what the interface to the add event listener is. I do apologize. We're a little bit off the roadmap here, but I think this will be a really interesting demo if it succeeds. I'm just going to look up what the interface for add event listener is, which is part of the Pyodide FFI. I'm just on pyodide.org looking it up. Add event listener takes an element, the name of the event, and the listener. Okay, so we'll take the element, the name of the event. Is change going to do what I want it to do? Probably not. Because change responds to changes in value and not to changes in internal content. Let's see. What if I do input type equals text area? Text. Let's see if that gives what we want. Sorry, I know this is a little bit of a long way around. Just thinking of like ways you could pass things between multiple threads here. I think also there's a possibility that we just in PyScript need to add some kind of API that simplifies this, right? Because this is now quite a long way around to do anything. But let's just see if it works. Target dot value times 2. A real show. Yeah, I know we're a little bit off the thing. I will go back. I will say for those who are watching this later, I will put timestamps in the description. So if you want to skip past this to the next thing, just go in the description and skip to the next topic of what's new in PyScript this version. But hopefully this is helpful to you who are actually developing solutions in PyScript here. The only other thing I want to do here is say, instead of displaying this value in text content, I will say, let's see, I will say my cont element is document.getElement by ID content, cont.value equals 42. I think I can initialize this to 0. Yeah, okay. So let's see if this runs successfully. Yeah, so I don't know if you caught that over on the right side of your screen there. When this code runs, it actually updates the value of this input block to 42. And now what I'm going to do is down in my other worker thread here, I should be attaching an event listener that fires when that element changes. And I'm just not 100% sure. Event when value changes. I believe the event is called change. Let's see. JS MDN event change in value. Yes. Oh, you know what's going to be? Let's see. I think this is going to be the input event because change only changes when the user actually changes the input, but not when the code actually changes it. Now we're down to the point in this demo where like I feel like I'm going to be messing with semantics for a long time and we're not going to actually get anywhere. So Littlebug, this is going to be a little unsatisfying for you particularly, but I'm probably not going to finish off this demo just for the sake of moving on. But I think you can start to see like by passing values through the main thread, either through the DOM or through a JavaScript object that you create there, you could start to sort of interlock your two threads and do different things with them. And I feel like messing around with the semantics of exactly what this value is are going to be unsatisfying for everybody else. But like I said, I will finish it out and we'll figure it out. Seems like a fair solution to seeing the limitations of the case. Yeah, thanks, Littlebug, for your understanding. I do want to press on, but hopefully this was at least a little bit helpful for those of you out there who are thinking about this stuff. Cool. Let's move on to some other stuff because we have so much more to talk about. Let's delete all of this code and start with a fresh script type equals py tag. So you may have seen so far that whenever I want to put something on the page, I'm doing from PyScript import display and display, I don't know, let's do display 1 plus 2, right? We should just put 3 on the screen. It's going to be the most exciting program ever. Hey, it's 3. So like I said before, display is the function that we use in PyScript when we want to output content to the page. But that said, there are lots of sort of existing Python programs that take a fully different approach, like print, right? So if I were to say instead print in this code, you will see that that doesn't appear on the page. The only place that appears is in our developer tools. And that's a conscious choice that we in the PyScript development team made. You know, the Python's standard out as a stream of text doesn't really map well in understanding to like how things go inside the richness of a web page. So we said, okay, well, print, which will output a stream of text, can go to the developer console. If you want it to appear on the page, use display, which is all well and good. But what if you want to run some existing Python code that assumes that its useful output is going to standard out? There's a couple different things you can do, but perhaps the simplest is to run your code with a script type PyTag that has the terminal attribute. So if I run this with terminal, there we go, we'll see that when our code loads, it bootstraps a pretty fully featured terminal for your code to be output into. And if I do a little asyncishness, I think this should work. I could say from async.io import sleep for I in range. My favorite example for I in range 5. Print I await async.io.sleep 1. Reload the page, and as after PyDI initializes, oh, I do this every time. It's just sleep 1. I'll rerun that code, and we'll see 0, 1, 2, 3, 4. So this is basically, you know, emulating a fully functioned terminal on your page, so that programs that you may already have existing that are writing to standard out to do their output can still function in a meaningful way. This also works with web workers. So if I do worker terminal async PyScript tag, we'll see once that worker initializes again, it will load its code and just run it directly in that terminal there. So this is the terminal attribute is the easiest way to get your code outputting outputting its standard out to a thing that's going to format your output in the same way that the terminal in your IDE would. Now we've sort of stumbled upon another really nifty thing, which is that combining the worker attribute with the terminal attribute gives it a few additional superpowers. For example, if I say import code, which is Python's built-in representation of how the REPL works, and I say code.interact and run this, and I think this should work, what I get is a fully featured Python REPL running inside of a terminal in the client's browser, right? That's pretty cool. And this is the real honest-to-goodness CPython REPL. This is not, to be clear, compiling anything down to JavaScript or pre-compiling anything to WebAssembly. This is the REPL. I don't know what name is inside of the REPL here. Oh, it's console. Oh, that makes sense. Console is what you'd expect in a standard REPL. And say for I in range 10, print I, and run it. Oh, I broke it. Now extending interactive console. What did I do? Oh no, I broke it quite badly. Here, let's rerun that. See what happens. Print. Is it a print thing? Print 1 plus 2 for I in range 5. Print I. Oh, ooh, weird. Oh no, something's broken. Hey, we found a bug. That's very good luck. So usually in doing these live demos, I find one bug in our releases, and we found one. And it makes sense that it's in the interactivity part that includes both the worker and the terminal, because those are the two biggest UI interfaces that we've added in this time. So that's very good. I don't know if Andrea is watching, who's one of our sort of lead devs who's been really critical in implementing both the worker and terminal features. But Andrea, if you watch this later, try this and see what's broken. So like I say, it is a fully featured Python REPL, and probably will have a release next week that corrects this behavior. Yeah, a little bug says, oh, it's a little bug. Hey, there you go. That's great. There's our little bug for this demo. So anyway, adding worker makes it run in a worker. Adding terminal lets it run in a terminal. I don't remember. We had much discussion before release. All right, I'm going to sort of put my cards on the table here. If you do input, does this work in a terminal now? Yeah, it does. Ah, very good. So input is a particularly gnarly function to handle inside of PyScript because it blocks your thread in order to handle its input. And we had a lot of back and forth about how this should sort of natively work in the terminal, and I wasn't sure what the resolution was, but it appears to just work. It's a name equals input. What is your name? What is your name? My name is Jeff, and I can say print name, and it gives you Jeff. That's great. Oh, Joshua's here. Hi, Joshua. Good to see you. Joshua says, input was my request. Super cool to have that functionality in the terminal. Yeah, for sure. This is something we've wanted in PyScript for so long, because especially because PyScript and Joshua's, lead project EduBlocks have this theme around like letting new developers dive into Python with no installation. How cool is that? And a bunch of intro programs just say, use input to request the user's name. And for the longest time, this did not work in PyScript. And now, as long as you're running inside of a worker, it just does, which is really, really cool. So that is the gist of the terminal attribute. I've got some more examples of it in the release blog post, which is linked down below. This is a fully featured xterm.js terminal, so it will do formatting. In fact, I'll tell you what, I'm going to copy in a quick example here. If I add a PyConfig tag, and I know we haven't talked about PyConfig yet, but we will, and I include the rich package, which is a package that does rich formatting in the terminal. And I say from rich import print, I think it's vampire. Let's see if this syntax is right. I should get a little vampire guy. So rich has all these fun features about like formatting and output, but one of them is emojis. And so because this is a fully featured Xterm terminal, I can use all of Rich's features that work in your native terminal in the browser, which is pretty cool. I feel like bold is somehow broken in the browser, but let's try the colors. Hello? And /magenta. Hello. There you go. It's not terribly magenta, but oops. But let's see if other colors make a little bit more sense. So this is not necessarily the way you would want. You don't have to use simple print statements to do this. But basically, if you have a terminal-based library, the point of this is it will basically just work inside of this terminal in a worker in the browser, which is really pretty cool. That's the gist of the terminal attribute. As I scroll down my list here, if there's any other attributes we're meant to add. Oh, Joshua says, no idea that worked. That's really cool. I know, right? It stuff sort of just starts working. Because we have a full copy of the CPython interpreter, Python code sort of just works. Just works. Joshua, who's done a lot of development with it, will probably say like, well, there's a lot of ways it doesn't just work. But try stuff and see what does work. And I think you'll be pleasantly surprised. Let's talk briefly about this PyConfig tag that I've just sort of thrown in here willy-nilly and what it can do. I'm not going to go super, well, I say this, I'm trying not to go super long into the PyConfig tag because it has not changed much from the previous release, but I know that there are a lot of people who are jumping in new to PyScript at this point and because of our new release and because of these videos, so I'm going to touch on all of its features briefly just to give you a place to start. I'd recommend going and looking at both the release post linked below and docs.pyscript.net, which has a list of all of these features. Let's clean this up a little bit. I will add some things here. So let's start with the packages tag, which I've sort of already alluded to. Packages is for installing additional Python packages. They can come from three places. If you just give it the name of a package, it will try and import it from PyPI and run it, like, the Python package index, where you get all of your other things when you do like a pip install. You can think of this as your equivalent of pip install. You can also give it a fully qualified URL to a wheel that you've built yourself. So if you're developing your own Python package or building a custom version of someone else's and you can build it to a wheel file, you can load that here. And I should also say there are some packages that are pre-built with the Pyodide distribution. Let's go to the Pyodide docs, which I've come to know and love so well. If I go to our packages built into Pyodide, you'll see that there is a list of packages that sort of come pre-included with the Pyodide distribution. And the reason for that is not because, they're special or they're the best. It's that they have extensions in C or Rust or maybe Fortran that need to be pre-compiled in a WebAssembly compatible way so that they can just run. So basically, there are like C extensions to things like AstroPy is deeply built in C and maybe some Fortran. Not an AstroPy guy. Basically, AstroPy has been pre-compiled to work on the web. So if you put AstroPy in your packages key, instead of trying to download the Linux version from PyPI and throwing up, what you're getting is a pre-compiled version that works with Pyodide, so that it mostly just works. I actually don't know enough about AstroPy to prove that I can actually run some code from there, but I can show you at least that it doesn't throw up on imports. It's that it's actually importing correctly. And you'll see it does dependency resolution, as normal pip installs would. So you get, in this case, AstroPy, but I also got NumPy. I also got PyYAML. So it's doing that full sort of dependency resolution there. That's the gist of the packages key. A little note from Josh. Workers in the new terminal has massively improved PyScript, especially for beginner use cases. Very little that doesn't work now. Testament to the great work done. Oh, thank you, Josh. Yeah, being able to run code in workers and throw them into a terminal, it makes Python feel like Python in a terminal in the browser. It's really, really very cool. Other things you can put inside of your pyconfig tag. One is the files table. So files, and this is TOML syntax. That's how you start a file here. One thing you might often want to do for your web applications is bring in additional files to work with. So let's create some additional file. I'll create a new file over here called data.txt, and in it I'll put, I don't know, hello world, this is a file, isn't it neat? And I'll save that. Let's say that's the super critical data that I want to work with inside of our Python here. I've thrown an error because I'm still importing AstroPy. We'll delete that. Inside of my files key here is how I'm going to get that data.txt into a place where I can work with it in Python. And the key thing to know here is that when you have a Python runtime running in the browser, when you do something that would normally interact with files, like with open data.txt in read mode, as print f.read, right? A pretty simple way of opening a file and getting the data out of it. Actually, let's do our display from PyScript import display, and we'll display the contents of that file. The key thing here is when I use this open statement, which is looking for a file in a file system, where Python is looking for that file is inside of the virtual in-memory file system that is created when the interpreter loads, when Pyodide or the Micropython runtime load. So basically when you initialize Pyodide or Micropython in your browser, you get a temporary in-memory file system that Python knows how to work with. So the trick is, how do we move content from other URLs or our server or whatever into that virtual file system so Python knows how to work with them? And the answer is with this file key. The files table is very simple. It just is sort of a source and destination map. So I can say I would like to map data.txt to data.txt. And if I haven't goofed this, I should see the contents of my file. Hello world, this is a file, isn't it neat? All in one line, just there. What's happening here inside of this files key is I'm giving it a list of a URL out there on the web where I'm loading my data from, mapping to a location in the virtual file system that I want that data to end up. So if I rename that location in my virtual file system, I call it local data, then the location that I'm referencing that data inside of my Python should change. You can see if I reload, I still see hello world, isn't this neat? I can also, this could be any data file that I had out there. For example, if I create a new folder called my data and I move my data.txt file into it, well, first when this reruns, it's going to break my example because it's going to find when it tries to open this location, what it's getting is actually the error message that was fetched when I tried to load that data.txt file. But I could say, okay, well, my URL is actually now my data/data.txt. If I reload that, it finds my content as applicable, right? So files key is just literally a map from URL to location in the local file system. Yeah. The one feature that got added really quite recently, which I love, which is super powerful, is the ability to do simple templating inside of this files tag. So let's say in my data folder, and again, I know this font size is small, but you'll just have to trust me. If I had a second file called names.txt, and it says Jeff, Littlebug, Joshua, who was here earlier, Piers, right there, some names. Let's say I wanted to load that data as well. I could say my data/names.txt equals names. I'll call it something else. Call it names.txt. And then down in my Python code, I can open that. I can say for line in f.readlines, display line. I guess it should probably be names.txt. So that we can actually see those actual things, right? So we opened a couple of files from the local file system, we printed them out, and so on. And let's say we had yet another file, which was called streams.txt, also in the My Data folder. And inside that, I said, today is stream. You can tell, like, really riveting content in the sort of the data of my app here. But again, now if I wanted to load that into my app, now again, I'm doing a copy and paste. I've got streams.txt. I got maybe it's underscore streams. Like, things start to get a little bit verbose inside of my actual files key up here. There's a lot of repetition. And that could be, if you're like me and you start seeing repetition in your code, you start to think to yourself, there surely must be some way that we can like condense that into like a for loop or something like that. Oh yeah, I called this file underscore streams because I'm a monster. But yeah, so we have all the content of our files printing here, but I have this like my data slash names, my data slash text, my data dash streams. Like, what if the name of that folder changes? I'm going to have to like undo a lot of copy pasting to make this work. So like I say, there is a very simple templating language built into this files key. And it works like this. Any key that is surrounded by curly braces is treated as a templatable object. So I can say, let's call it folder equals my data. And now in these next three places, I'm just going to say folder. So now if I rerun that, we should see the content of my page hasn't changed. But now if I come up here, and again, apologies for small text size, if I rename the my data folder to my good data, we should see that it breaks our code because it, of course, you've got all these error messages. It can't find those folders. But now instead of doing a find and replace across all of my files, I can just say my folder template is equal to my good data. Good data, I guess I spelled it as. And that should reset everything. So this is a really simple way of like adding templating into this files key so that you're, reducing the amount of copy and pasting and retyping that you would have to do. This also works on the destination side. So I could say maybe file type equals txt. And then over here, I could say, actually I could do all of these, I think. Let's find out. I can say file type. File type. If there was some world where my data started changing. Local data .txt. I've broken something clearly. Maybe we'll do this just on the destination side and see if this works. I wonder if underscores aren't permitted. That would be interesting, and not how I thought this worked. Let's see. There we go. So if you were in some weird situation where your file type might be changing, and this is, of course, a very made-up example, right? You can do templating on your output side as well. If you had maybe things going to, maybe a more realistic example is doing a local folder where things are going to, and just saying just // So I could say local folder names .txt, right? And then if my local destination changed for the sake of my Python code, I wouldn't have to change it in all of these places. 1, 2, something like that. Regarding files, let's see, Littlebug says, regarding files, are there size limitations on the virtual structure? There are, because there are limitations on your stack size in WebAssembly. So there's a couple different limitations there. One is WebAssembly is currently only 32-bit, right? So you get a maximum of, I think, 4 gigabytes of addressable space, and that's for the whole WebAssembly structure, right? Which maps fairly well one-to-one, like a 5 gigabyte text file, or 5 megabyte text file is about 5 megabytes when it's sort of represented in the WASM compatible data format. But 4 gigabytes is sort of absolutely max. I do think there is also a limitation on like raw object size, which is, I want to say it's 2 gigabytes. And then of course you'd be limited by like your actual memory of your machine. I I think those are the major 3 limitations. I'm trying to recall if at current there are limitations to like maximum memory usage per like browser thread. I think you would hit those after the WASM limits, but that would be one to Google. Those are the ones that leap to mind, if that makes sense. So yeah, so for things like, names.txt and data.txt, you got all the room in the world, right? Like, feel free, go wild, put CSVs and data files in there. We've seen it a couple times float through PyScript or like the Pyodide GitHub issues tracker when people are like, I want to load a 12 gigabyte CSV file in to train my TensorFlow model in the browser. It's like, well, that is a more complicated proposition for sure. And you start running into those limits. That is the files parameter of PyConfig. I said I wasn't going to go super deep into these, but yeah, here we are. Also, files is new. Files is new in this release, and so it's worth talking about a little bit. The only other ones that I think are worth talking about here, and I think I can do briefly, I guess we'll find out, the plugins key. So plugins have changed really radically between PyScript Classic and PyScript Next, and they deserve their whole separate, like a whole new blog post and stream and all these things. I'm not going to go into plugin development today. Right now, the plugins key is basically a list of the internal plugins that PyScript comes bundled with that you want to disable. So there are only 2 of them just now, and I believe one of them is the plugin that handles displaying the errors in this way, right? So if I have a division by 0 error, it'll pop up in this big red box. I believe I can say, is it not error? This one I may have to look up. Let's see. Let's rerun that. Basically, is a way to sort of disable the error plugin. Let's see, plugins equals. I thought it was plugins not error. Let's see. Let's run that again. Division by 0. Yeah. So this is something if you want to disable the view of this error plugin in your implementation of a PyScript website, there is a way to do that. There's also, I believe, you can disable the terminal from displaying if you really wanted to, although you could always just not include the terminal tag. So I'm not 100% sure what the full use case is for that. But anyway, this is a way of sort of disabling which of the built-in plugins are available. And right now, that's just error and terminal. And then the last option for the PyConfig tag is one called interpreter. And all this is a specification of which version of your given interpreter you want to use. So let's see, what's going to be a good way to show this? I think the way is going to be to do this. So basically, each version of PyScript comes bundled with or implements a particular version of the Pyodide runtime and the Micropython runtime. But for experimentation purposes, you might want to run with an older version of Pyodide or a bleeding edge build of Pyodide that we don't support yet, or a new build of the Micropython runtime, and so on. And so that's what this interpreter key is for. If you pass it a string or that represents a version number, it will try to load the version of Pyodide or the Micropython runtime that matches this version number. And I was just trying to remember how to get Pyodide to spit out its version. Let's see. And actually, let's figure this out, because this is one of the ways that I often develop with PyScript Online, is I just start asking, because I'm running a full Python interpreter, I can just start asking the objects about themselves. So I'm going to say from PyScript import display dir Pyodide. So like, let's grab the Pyodide module and just like have it spit out all of its attributes, and we'll see if they include anything. Oh yeah, so it has a dunder version. So if I display pyodide.dunder version and run that, well, I should see, because this is currently commented out, right? So currently PyScript, the current PyScript release bundles pyodide 0.24.1, but if I use my interpreter key to specify a different version, we should see the other version, right? That's sort of as you'd expect. What I really want to make clear, each release of PyScript is designed around a given release of Pyodide. Like, we guarantee that PyScript 2023.11.1 is compatible with Pyodide 0.24.1, right? That's the sort of bundled release. If you use this interpreter key to specify a different version, I mean, go for it. but we don't guarantee cross compatibility or backward compatibility or anything like that. Like, I think if I do the oldest version of PyDide that I have ever used, things break immediately, right? Let's see. I think PyScript Alpha used 20.1. I don't know if this will work. Yeah, no, for sure. How about 21.3? That was 2 releases ago. That might work. Oh yeah, so that works. So like, you can probably go back and forward a few versions. The PyDide API has really stabilized in the past few releases, so more recent releases are likely to work. This is really meant for like, if you are doing A/B testing with like releases of PyScript and you need to say like, hey, my code used to work with PyDide 23.2, will it work with 24.1? Or I'm custom building PyDide to work with my system, use this interpreter key. But it doesn't mean that we guarantee compatibility with any version. I think that makes sense to all of you good nerds out there. That is the PyConfig tag. I've been going now for an hour and 20 minutes, so I need a brief T-sip. So give me 1 second. And I'll remember to unmute myself, which is always the challenge before we carry on with more things. Let's see, what else to talk about? Let's talk about event listeners, which are both really cool in PyScript and somewhat different in this release. So let's give ourselves something to work with here that we can interact with, like a button that says, click me. And there it is. It's a lovely button called Click Me. I guess we'll also still run this PyDide code. Let's say I'd like this button when I click it to run some Python code. How might I do that? Well, in PyScript next, it looks like this. I will define an event handler. I will say this is my handler function. Handler functions always take a single argument, which is the event object that the event itself generates. If you didn't want to use that argument, you could always do a star args and just ignore it. But I will, in this case, from PyScript, import display. I will say display, I got an event of type event.type. So this is going to be our event handler. So whenever this handler is triggered, it's going to tell us the type of event that triggered it. And there are a couple of different ways we could go about hooking up this handler function to our button here. In this case, I'm going to use the py event syntax. It's a py-click equals handler. When I run that, I should see a couple things happen. Oops, what happened here? Syntax error expected. Well, you have to write your Python code correctly for PyScript to know what to do with it. So I got to put that colon in there. We'll run this again. And now when I hit click, I should see I got an event of type click. So by using this py-the name of an event system, what I'm doing is telling PyScript to look up this object in the global namespace that PyScript has and attach that as an event listener to this button, right? This event name could be any event that the browser supports. So I believe mouse over is one that we could do. So in this case, if I hook up a mouse over listener, every time my mouse mouses over that button now, I get an event of type mouse over, and so on, right? So we're not limited just to py-click. We can do py-mouse over. We can do, I think, py-hover. I don't know how often py-hover events or hover events are generated, but let's see. Yeah, I think that's going to be a slightly different thing. So py-click obviously is a very common one that we would use, just because that's really, really quite handy. But that's the gist of it. You give an attribute on the page, you give an element on the page, an attribute which looks like py dash and the name of some event. You pass it the name of a handler in the global namespace, and when that event is seen on that element, it runs that handler. That's all there is to events. A couple cool things that are true here. This works in PyDide and also Micropython. So if I make this a script type mpy and mpy-click, what I should see is the exact same thing, except did you see how fast that loaded? You can tell how fast it loaded, by the way, because by default, elements with a py-event attribute are disabled until PyDide has loaded. So if you've noticed while I've been running this that this button is grayed out for a little bit, that's PyDide loading, and only when it's loaded is it going to enable that interface, because that's when it's sort of ready to receive events. So with PyDide here, when I reload this, I'm seeing, you know, my usual couple seconds of initialization time. If I do make this an mpyclick event and run this in Micropython and I save it, you'll see it's like microseconds until we're interactive, and the code is working exactly the same. This is one of those areas where it's like, hey, Micropython really starts to make sense if I need a site that's responsive very quickly. You know, you don't have to necessarily use like buttons or inputs to handle these pyclick or mpyclick events. Like if I had a div and I put some text in it, put some lorem ipsum text in here, I could of course add a py mouse over. I should probably do an mpy mouse over. mpy mouse over is how that's spelled, equals handler. I reload that, and now whenever I mouse over that div, I'm getting my mouse over text here, right? So, you know, we often think of event handlers as being associated with buttons or form inputs or text inputs, but you can use them to respond to sort of anything that you might have on your page. One cool difference this actually was true in the last release of PyScript Classic, but is still true, is that in early versions of PyScript, these event listeners were sort of looked up once on page load and then never again. So if you had any kind of interface that was dynamically adding or subtracting elements from your page, this wouldn't work. But now element lookup is dynamic. So we'll call this the little bug challenge, where I try and make up a demo live. And we'll do this in PyDide just because I'm more confident in my API knowledge there. What I will do is use that FFI we were looking at earlier to dynamically inject a new element in the page. And it will still have its event listeners working. So like, let's say from PyScript import display and document, I'll say new button equals document dot create element button. I'll say new button dot text content equals I am new, and I will say new button dot set attribute pyclick, and let's create a new handler. Let's use our existing handler, pyclick handler, and I will modify my handler so it prints out the text of what we're printing. I will say, instead of I got an event of type this, I will say I am event.target.text content, and I got an event of type so-and-so. And I would need to add this button to the DOM, so I can say document.body.append new button. I think it's append. We'll find out. There we go. So you'll see there what happened is when originally I had one button on the page. When my code finished running, I actually created a new button in code, set its internal contents, set its attribute called pyclick to the value of handler, and then shoved it onto the end of my document body. So if I run that again, here's PyDide loading, Python code is running, it shoves that new body on here. And what I should see, unless I've made an error, and we'll all find out together, is that when I click this, I should have the same event handler that I did before. So when I click the click me, it says I am click me, and I got an event of type click. If I click I am new, I get I am new, and I got an event of type click, right? So these event handlers are basically dynamically processed whenever there is a change to the DOM. So you can add and subtract DOM elements as much as you like, as long as they have these matching attribute names like pyclick, pymouseover, and the valid event handler name. They will just work. Which is super cool. Really helpful for building reactive UIs that incorporate PyScript. So things that don't work with event handlers currently is workers. And this is actually a big discussion that is happening right now on the PyScript GitHub. And you should absolutely go and check it out and leave your feedback and comment about how this would work, right? Because you can absolutely see the value of something like, if I get rid of some of the shenanigans, saying like, hey, I would really like my handler code that I'm running here in PyScript. I would love this to run in a worker. Like, I'd love to say, hey, when I click this button, reach out to my worker and run this code. Seems like a totally reasonable thing, but with the semantics we have currently, it's like it's a little bit It's a little bit unclear how that would work, right? Because if you recall from our discussion, half an hour ago, these two script tags are two separate threads. And two separate workers, two separate threads. They both have, event handlers named handler. What should this reach out to? Given, honestly, that we might have yet another thing that isn't in a worker, right? Like if I have a handler that's on the main thread, in my main thread PyDot interpreter, I have a handler called handler, and in this worker I have a handler called handler, and in this worker I have a handler called handler. What the heck is this supposed to refer to? So it's a problem both of implementation, right? Because reaching out to a specific worker and holding a reference to its event handler is non-trivial, and also like just the API, like what should this interface to a specific worker look like, are kind of baking our brains a little bit. So if you have opinions, if you're like, oh, well, it should be like, I don't know, you give this worker like a name, and then it's like PyClick the name, or maybe it's like the name dot handler, or maybe this takes another attribute called like worker handler equals 1. I don't know. There's lots of different ways you could skin this. If you have opinions, please come to the GitHub discussions and leave your feedback. Because we've chased through a lot of ideas and we haven't really found one we can all agree is good. Or maybe we shouldn't do it at all. There are actually some really significant technical limitations to saying, hey, grab an arbitrary reference in a worker to a function and run it when I want to. It's a little bit challenging, and there's some discussion in those GitHub discussions as well as to why that is. So this is one of those areas of like active development, and if you want to move it forward, come hang out with us. That's to be totally clear, because I see some new faces in the chat. That's how I got involved, right? I saw some issues that I like wanted to get involved in and was passionate about, and then I just kept submitting like pull requests and issues and commentary until they were like, hey, you should just be a maintainer. So here I am. Like it's a really cool community. I love this core dev team. So like just, I don't know, come give us your feedback and get involved. We'd love to see you over there. Anyway, that's event handlers. I'm just scrolling through my notes over here to see if there's anything enormous that I've missed for new features. I want to sort of hit on a couple of like deprecations and elisions that we've made, just for users who are coming from PyScript Classic, or really those of you who are new to PyScript, but who might be reading like tutorials that were written before the previous version, which may or may not be totally accurate anymore. Let's see. I think that is, we've touched on from PyScript import. That's a totally different thing. I guess the one major thing that I want to touch on is this. Here is like the one feature that we have not re-implemented in the new version of PyScript, is the thing we used to call PyRepl, which you will recall if you used PyScript Classic, which I will just load up here. Let's do this. Let me load the previous version of PyScript, and I can show you what it was, so that when you're looking at it, you'll know. Let's get rid of our service worker here. In previous releases of PyScript, we had this thing which we called the PyRepl. Oops. Oh, right. Oops. Come back. Come here. There you go. All my windows are running away from me today. This was called PyScript.js, and bring that back out. And once this loads, if I don't have an error, PyScript.js failed to load. Well, that's no good. The whole point is that it loads. 2023.05.1 was that release. And I might as well put our CSS for this back in here. Release is 2023.05 and PyScript.css so that it styles correctly. There we go. There's our old familiar loading screen that we've done away with now. So we used to have this thing, which we called the PyRepl. And what this is a code mirror editor, which is a JavaScript library for building editors that are built into web pages. And We called this the PyRepl, like the tag is py-REPL. It's not really a REPL, it's more of like a notebook cell like you'd see in a Jupyter notebook. But anyways, it was a way of like injecting one of these editors into your HTML. And back in the days when we really only had one interpreter and it was main thread only, this made a fair amount of sense. And what's cooking our brains a little bit now is we'd really like this to run in a worker as well. And again, there are implementation details around that we are still parsing through. The other thing that we'd really like to do is, again, now that we have the ability to have multiple worker threads, is start to bundle these REPLs together into something that can be a little bit more notebook-like. What does notebook-like mean? Fair question. Do we want to have a system where if you have multiple of these cells, you could, like a Jupyter notebook, if you change an earlier one, run a later one? Do we want to have the ability to like download or export all of the code in your multiple REPLs as a single file? If these are running in a single worker or multiple workers, how do we reference that worker inside your HTML? So you can say, hook up this REPL to, this worker, and this REPL to another worker. I'm making up this syntax, right? So there's both API considerations here, and there's technical limitations on, like, again, hooking up a interpreter inside a worker to run arbitrary code on demand. It's a little bit tricky. This is 100% in some form a feature we still very much want, right? And a feature that I personally use all the time in PyScript Classic. Like, it's really cool to drop one of these editor functions into your web page and let users, run their own Python code there. But since we've sort of broken apart and remade the world for this new release, both the technical limitations and the API around this are a little muddy. So this is another area where I would really encourage you, if you use this in PyScript Classic, or if it seems like a thing you would use in this new version, there is a proposal open on GitHub right now that Fabio and I authored just this past week that talks about like one way that this could work, one way that this semantics could work. Probably PyRepl is not the name, right? It could be like maybe it's PyEditor, maybe it's PyCell because it's kind of like a notebook cell. I don't know. Lots of thoughts there, but like I say, if you have opinions or this seems neat, or you'd say like, hey, if this worked this way, I would use it. Again, please come over to the GitHub and leave it there. That's github.com/PyScript/PyScript. Real easy to find. So in any case, for those of you who are migrating existing PyScript applications to the new version, this is I think the biggest thing that we have currently left out. I know it is intended to come up in a release quite soon in whatever new form it takes. But if this is critical to your use case, you may need to wait for the next release for that to be possible. So just wanted to throw it out there. We're working on it. It's really important to us, but we want to if we're gonna break it and remake it, we want to get it right, if that sort of makes sense. What else has changed? I want to run through real quick a few little things. This is mostly for folks who are coming again from PyScript Classic, things that have changed in the most recent version. That we have either left out or are implementing differently. We used to import a bunch of stuff into PyScript for you. So you've seen me mess this up in this demo a couple of times. I've just been like, display, hi. Actually, here, I'll tell you what. I got to be in the most recent version of PyScript for this to make any sense. Let me uncomment those bits of code out here. If I just do display, hi, I get name error. Display is not defined. It's like, well, because I have to do from PyScript import display. And then everything should just work as normal. The reason I have messed this up is because in PyScript previously, we used to just like automatically import a bunch of names for you. We used to do, basically before your Python code ran, the Python devs in the background would do from PyScript, we would do import JS, import PyScript, and then from PyScript import element, which is dead, element no longer exists, display, and HTML, right? So you really could just be like display hi and it would show up. And what we found is like we were trying to be helpful, like, oh, users are going to use display all the time or from JS all the time. And it just confused people. They were like, why can I use this, built-in function without importing it? Where is that coming from? Also, like, a lot of what we would see is people would type this into their IDE and the IDE wouldn't know what to do. It's like, hey, display is not defined anywhere. That's super weird. Whereas if you at least had to type from PyScript import display, your IDE says, well, I don't know what that package is, but clearly you do, so no error here. So anyway, we've done away with all the automagic imports. You have to import your own display function, HTML function, and JS if you need it, and so on and so on. So anyway, little note, but I mention it because a lot of the tutorials that have existed up to this point assume, rightly, that you can just do this. You can just say display hi, and you can't anymore. We took that away. No more magic. Explicit, better than implicit. Just a little change. Since I've mentioned it, actually, some of the logic around that HTML helper that I mentioned a moment ago has tightened up some. So if I do from PyScript import display and HTML, that HTML helper is there to help you actually put tags into your strings if you want to. So if I just do display h1, this is a header /h1. This actually came up on the Discord just the other day, so it's very fresh in my mind. What PyScript tries to do is say, hey, I'm just going to output exactly what you typed in here as literally as I can. So we see like the brackets and the h1 and everything right in our HTML. If what you want to do is take a string of HTML and output it to your page, you can wrap your string in this HTML helper, and that's going to say, okay, let this string be interpreted as HTML and stick that in the page. So you can see this turned into a proper h1 header tag instead of like showing the brackets over here. That logic has gotten somewhat typed up, so if you've been trying this before and it was broken, hopefully now it works. If it doesn't, come file a bug. The only other thing I think it's worth mentioning that we have currently not implemented in PyScript next, I guess two other things. One is, we talked a lot about the terminal attribute that these script tags now have. In PyScript Classic, we had this notion of a PyTerminal tag, which was a way of sort of capturing the standard output from Python. That does not currently exist in our in this current release. The way to get a terminal on the page is to put a terminal attribute on your script tag, so not a huge change there. A couple other attributes that we have gotten away with. You used to be able to, if you had an element on the page that you could reference, you could do something like output equals foo. And this would say, take the standard out of this script, like print, let's see, oops. Like I could say print 1 + 2. And in this case, this standard out would be routed to the element in the DOM with the ID of foo. That is not currently implemented. Neither is the standard error attribute, which is say if this throws an error, put that text into the div with this ID. That's just kind of an implementation DSO that like not too many people were using. I do think we'll see attributes like these come back in a future release, because selfishly I use them for some very specific things, and I'm a maintainer, so I can pitch features sort of as much as I want. Although you should too. Come pitch features. We would love that. But I put these in the first place. I'm hoping to put them back in for some very specific use cases where you're running sort of desktop Python code in a PyScript environment and you want it to sort of appear in a different place on the page. I mention it because, again, there are tutorials out there that use these attributes, and I wanted to mention they are not currently implemented in 2023.11.1, but they hopefully will be in future releases, at least if I have my way. Let's see. I think that is all of the major features. We'll touch briefly on Micropython. I'm going to tease two more things, and then we will wrap it up for today. Micropython is super cool. You should absolutely go and play with it in the browser and just see how fast it is. One feature that I know does not, well, a feature that I know exists, and then a feature that I know doesn't exist, is MicroPython comes with its own set of standard libraries. We talked earlier about how MicroPython, doesn't have like NumPy or Pandas or SciPy, and that's because it's like its literal underlying object model is different, so it wouldn't make a lot of sense. But MicroPython does have its own standard library, which you can look up in their documentation. And so I can still do things like from math import, let's find a math function off screen here. How about exp? I can say, let's see, from PyScript import display exp of 2. Whoa, I've broken the world. What's happened here? Oh, display.py. Object of type dict view has no len. Ah, okay, yes. So this I actually ran across the other day when I was playing with MicroPython, and I will share it with you as a feature. Because MicroPython's object model is different, if we want to output a string, we need to explicitly cast our output to a string, right? This might be something that we tweak on the PyScript side in a future release as well, right? What's happening here is we are trying to trying to treat an integer or a float as a string, and while CPython is very graceful about that, MicroPython is not as grateful. If you cast it to a string, things work much better, right? So the point of this demo was you can import from MicroPython's standard library. My pro tip on the side is that if you want to treat it as a string, cast it to a string. The thing that does not currently work in MicroPython, although we hope it will work soon, is installing additional MicroPython libraries. So MicroPython has an additional number of web libraries that you would normally be able to access through a tool called UPip, or Micropip, they probably call it. It's spelled UPip. They probably pronounce it Micropip. Because of the way that we are currently integrating MicroPython in the browser into the network requests, we don't currently have a way to do mpy config packages equals collections, which is one of the things in this web repository. So if you were running MicroPython on your desktop, you can do upip install collections. This does not currently work in the browser, which is a bummer. It's a limitation. It's the dance of doing network requests from inside of a browser window is a lot. it's complicated, so lots to be figured out there. But that is coming soon, and that's a thing we have been requested, and we hope to be able to get that working soon. But I mention it so that if you're playing around, you're not too downhearted when you discover that in a little bit here. So yeah, that's the sort of MicroPython note that I wanted to leave you with here. And the things that I will sort of tease as a way to close out. And if you've made it this far into the hour and 45 minutes of what's new in this stream, thank you for making it this far. We know that there's lots of different ways that people learn about PyScript, from Twitter, from the Discord, from the GitHub issues, from Reddit and Stack Overflow, from these videos. And so in an effort to have an additional way that people can learn about what PyScript is and what it can do, I personally have launched a thing called PyScript Recipes at pyscript.recipes. And it's just an additional way of thinking about how you learn about PyScript and what it can do. Obviously, I have not pushed our updated docs for the current release. That should come in the next couple of days. But I did just want to share, this is another way if you're looking for tools and techniques for how to accomplish something with PyScript or Pyodide. This is a recipe for you. So we've got recipes for, how do you install Python packages? You can use pyconfig. If you want to allow your users to upload files for you to interact with, here's a simple set of code that you can copy and paste into yours to just make it work. Or if you want to have them download files, or have some code that executes on the JavaScript side only when all of your PyScript code is finished, or things like that. It's got a recap of some of the ways that you can interact with JavaScript that we talked about earlier. Ways that you can import objects from JavaScript into Python, or export objects from Python back into JavaScript, and so on. And this is constantly growing. Someone had a question the other day about how do you interact with a color picker in PyScript? I want to have this app where it runs PyScript and then allows users to pick a color. And so we wrote up a tutorial about oh yeah, well, browsers have a color picker. Here's how you can integrate it into your PyScript app. So this is growing all the time. So if you have tools and techniques that you have developed to work with PyScript that work, I would love pull requests on this. We can build everybody's knowledge, and hopefully this is a real easy way to remind yourself hey, what was that link that he said that you have to put on your page to get this work? Or how do you use pyconfig to put packages on there? It's another way to go. I would also be remiss if I didn't just show you pyscript.net, or docs.pyscript.net, which is our documentation, which has this great user guide that allows users to sort of see what everything is going on. And I will go to the latest version of this. User guide has lots of features about like, what is PyScript? How would you write your first PyScript app? What is the architecture of a PyScript app, and so on. Nicholas especially has been really working, one of our core devs, Nicholas, has been working very hard on these docs. I think they're really quite good, and they really walk you through some of the, what is PyScript built on top of? How does it sit on, inside of your user code, over your user code? A really great look at how PyScript works and all the features that it has that you should check out. Yeah, I think with that, that's with a couple of significant digressions, everything that's new in PyScript 2023.11.1. If you have questions, if you have comments, if you have concerns, thank you for those who've been asking them live. Please feel free to leave them in the comments on this video. I would also encourage you to follow the link in the description to our Discord, where a lot of our community members hang out and all of the core maintainers hang out. That's where we actually like hold conversations about new features and debate new things and say, hey, can someone review this PR? So come hang out over there and you'll see PyScript being built from the ground up, as well as to have an opportunity to like see what other people are making, ask questions, solve problems, and so on. Of course, come over to the GitHub, github.com/PyScript, and check out what the issues are there. There's a couple of key discussions going on now that I've mentioned earlier around how events and workers work and the PyREPL/PyNotebook. And that will be a really good way if you want to jump in and start making things. We would love to see you there. Thank you to everyone who joined us live, and thank you to everyone who's watched us later. Littlebug, Joshua, Piers, thanks for joining us. Until next time, thank you so much. We'll see you right after the next release. Catch you soon.